Hello, I'm Steve Rinsler. Welcome to this session in which we will explore the physical internet, what it actually is, how it will come into being, and joining me is Ben Waller.
Hi, thanks Steve. This should be interesting. I look forward to discussing this topic and hopefully explain what it all means.
Well, let's get started. You and I know what the physical internet is, and we've worked together for a while on it, but how would you describe it?
Okay, so the physical internet is a way of describing the application of digitalization at scale. So the internet, if we go back to the internet itself, that works by agreeing how information is exchanged, how it's bundled and packaged, which allows for efficient shared channels for sending that information from one user to another. Physical internet aims to replicate that process to transform the transportation of goods, all global supply chains and forms of digitalization, so that the data on all transport needs and actions are automatically digitalized. Replicating all real-world capabilities and physical movements as digital information. So digital information is then produced that can be used to optimize in the real world the flow of physical goods. And the aim is to design a system that generates self-organizing flows of goods through shared transport systems.
That sounds involved. It sounds interesting. The data flows are organized to mirror the real world, but there's an awful lot to unpack there, an awful lot to take in. Firstly, your last comment on self-organizing flows of goods through a shared transport systems. What does that really mean? And why would that be a good thing?
Okay, so imagine you're writing and sending an email. That data is packaged, it's coded, it's bundled and sent to a destination reader via a series of shared systems and exchanges. It'll be very time consuming, expensive and slow to do that manually as a process, and to do it via a system using a system yourself that was different to the system that someone else was using. So, you know, with the development of the internet, we developed codes, rules, standards, a language, you know, obviously HTML, but lots of others, lots of coding languages that standardized how information is packaged, how it's moved. So this data exchange is fully automated, which means we can send emails to each other quickly and reliably. And the optimization of the movement of that data from sender to receiver is a completely automated process, which makes sure that the information is sent in the most efficient and effective way, making the best use of global IT capacity and the network processing and exchange. And yes, using digitalization to do the same to the movement of physical goods offers the possibility of automating the planning and organizational process, making the best use of real-world capacities and networks, saving money, time, improving on-time reliability, the robustness of user experience, and saving energy and CO2 impact as well. So, I mean, think of your everyday experience. Think of how Google Maps or Waze optimize routing. You know, logistics service providers use routing optimization continuously, both from a transport point of view and drops type of organization. But we're talking about doing the same thing with all logistics capabilities. So sending goods through all available resources, including warehousing, ports, and so on, through shared services. And the benefits, therefore, are shared between the users for those sending goods, those receiving goods, those moving or storing them, and for everyone, the negative impacts of transport and distribution are minimized.
So the physical internet is making the organization of transport and logistics more like the movement of data in the internet. using protocols? What do you mean by that word?
Yes. Well, just as the users of the internet want to move information around with minimal cost, so in the transport world, we're looking to do the same thing. I guess one of the differences in the virtual world, moving data via an indirect route can be optimal. So, maybe going from here to India via servers in the US. Although from an energy use point of view, that's probably a consideration even there. In the physical world, moving goods requires consideration of the distance and impacts of route and mode of transport. But the potential for improving the efficiency of transport and logistics is huge. Well, I think I'll come back to the protocols point in a bit more detail in a moment, but effectively what you're doing is agreeing a communication method by which the data is effectively standardized into one language.
Okay, let's park a little bit of technology for a second, but it's clear that the potential for optimization is huge in the real world. I mean, millions of items are dispatched to millions of locations on a daily basis. You only have to look at the post office lorries in the UK that have some 15 billion or something on the side of them. I mean, the numbers are really huge. And it's well known that there is a lot of waste in the transport networks, and there are figures like 29% empty running that are quoted quite frequently. So we have partially and fully empty trucks running around. It's true for the trains and the goods vehicles on the trains. And we know that the potential from collaboration is largely untapped. But if you're a supply chain manager, you tend to prefer to keep your operations dedicated, particularly if you've got any scale, and separate from everybody else rather than shared, because that's the only way you think you can guarantee that you'll be able to meet the service levels that you've agreed either with your company or with your customer. Carriers and third-party operators do try and identify opportunities where they can, and these savings are passed on. Nobody sits down and tries to sort out how to share the savings. The savings come through in the price. But collaboration is difficult. We know that. I know that from my working life. And largely it's because of the sharing of information is just so difficult. So how do you overcome these barriers?
Yeah, good question. I mean, I think you've well covered the barriers, which are largely, I think, they're several-fold, really. I mean, as you say, the largest 3PLs are often unable to identify flows that could be combined, and if they can't see it, who can? Because they often see more traffic than anybody else. I mean, we'll come on to trust later, which I think is a key barrier, but just knowing what's happening and visibility is a key question. So what the physical internet offers is the ability to run a many-to-many service, a bit like a postal system, or pallet networks even, but the service levels and particular requirements of most freight logistics is such that much more granular control is required than you'd expect in a postal system or pallet system. So the physical internet offers real time of information that automates the sharing and optimization of freight movement in a secure way of the detailed requirements, including service level agreements, that respects commercial sensitivities of people collaborating on transport who may even be in the same sector, potentially even competitors, and therefore confidentiality. Okay.
I think what you've just said is really important. So how do we actually make the physical internet happen? How do you share the data, for example?
Okay, so before you can share data on what to change to optimize, first of all, you being the person offering the optimization service to LSPs and users, end users, need to create a virtual model. A virtual model that allows you to optimize the real world flows in real time. And to do that, you have to know what is happening in real time, just as a sat nav takes data on real time traffic.
For example, trucks have GPS. Most ships and barges have those too. Trains are tracked by operators, need to be, just to make sure you don't get two trains on the same track. But don't we need to go beyond that to the detail of the freight, and how will that information be gathered and then managed?
You need to combine the existing data that companies use to manage their operations today. This includes information that doesn't change, so fixed data effectively. So things like case dimensions, truck capacities, and then you need to add to that more dynamic information, such as orders, which are constantly coming in, dispatch information, predicted movements for replenishment and so on. And then on top of that, the next step is a key thing that the physical internet offers, which is the gathering of dynamic real-time information that isn't already out there, that can be known and modeled. This means making a digital twin of everything in the real world.
Hey, hang on. We don't have many twins in our family. We certainly don't have any digital ones. But what is a digital twin?
Okay, yeah, more jargon. A digital twin is a replica of an object in the real world. One that carries all the key attributes attached to that item. So let's take a refrigerated trailer, for example. It records and creates a digital model of that refrigerated trailer. The dimensions, the capabilities of it, the key range of quality measures such as temperature control or vibration. So I'm going to show a graphic here that will help hopefully explain a little bit. So digital twin of every physical object is made possible by taking existing digital information on the physical logistics ecosystems, orders, assets, and goods. This information comes from suppliers and manufacturers, retailers, service providers such as hotels, including the information on the freight that needs moving. Information from LSPs, carriers, freight forwarders, including potential asset utilization opportunities, using digital service providers to share that information with key customers for that data. So, for example, passing key data to customs and excise authorities and insurers and asset managers, for example, those who own shipping containers. Let's say for the connected pallet of goods, for example, this virtualized, this pallet in the real world is represented by a digital twin in the virtual world and data hubs. And this allows simulation and optimization. Think of it as like constantly inputting into a simulation model. So this virtual model can then provide logistics network users and service providers with real-time optimization, but also strategic and planning insights too. And to make this possible, the virtual model must firstly replicate the real-world relationships, including service level agreements. Secondly, integrate external data flows such as orders and real-time live updates. Thirdly, make use of historical data to help forecast and predict real-world activity and trends, such as demand seasonality, traffic congestion, for example, and replicate the physical environment, such as the reality of moving around a port environment. And these virtual models must be able to offer on-demand solutions through data hubs, through portals that also provide a full record of the events as they happen and the transaction details that result from that. And this record can be enabled via an automated and distributed, i.e. shared data trail, often described as blockchain. So investment will be required to make the cargo connected that we've been talking about, requiring additional expenditure beyond just joining up today's existing connected infrastructures.
So how does connected cargo allow optimization?
Okay, it's probably worth me showing a graphic here. So cargo will be connected via the conveyance equipment, so the transport equipment, so a connected pallet, container, stillage, unless a bulky item such as a tractor tire, which could be provided with an individual tag, think like an RFID tag, for example. The connected cargo then becomes a transmitting, as we've said, the use of sensors to monitor temperature or vibration, which will in turn mean updating the digital twin in the virtual model and data hubs, so that any information coming from those sensors, from those connected conveyance equipment, updates the virtual model. This continuous updating of the digital twin allows for optimized solutions and instructions. For example, redirecting a flow of cargo through a congested port and warehousing system, which allows real-time execution of change of instructions. So if necessary, immediate redirection once operations are already in progress.
That sounds really challenging, Ben. So how is the data collected and to make all this happen?
Okay, so every item moving through the system is effectively allocated a unique ID, and data is automatically created as the connected item moves through the system, as it interacts with other connected devices, gateways, and so on. As we've said, some data related to the particular item is static, such as the loading volume of an empty container, whilst other data is dynamic, such as location and temperature. Sensors gather the dynamic data, and such as temperature, and location is gathered through location mapping or gateway indicators, using geofencing, for example. And the use of dynamic data allows two things. Firstly, an optimized solution to the consolidated flow of goods, optimizing both at a local and granular level, such as vehicle fill, and at a much bigger system level, such as the best split of volumes through two different transport routes, optimized for a range of efficiency gains, such as backhaul vehicle fill. Secondly, a single record as packet of data, a single packet of data as a record, is an accumulating and transactional chain of events, and is recorded to create an auditable documentation of what happened, what actually happened from dispatch to destination, replacing all the need for paperwork, errors, and batching of any auditing and checking of information.
Well, one of the things that supply chain managers are concerned about is that their supply chain is special. So if my systems already describe my supply chain in a specific way that is different to that of another company in the same sector, and are we talking about mixing flows from many sectors? Do we then have to translate our data into some form of common language?
Basically, yes. So the physical internet does exchange information in a standardized way as packets of data, and so requires an agreed way of describing the physical infrastructure and the goods that are moving through it. The networking protocols must be agreed and understood, just as internet protocols ensure standard ways of splitting data and exchanging, addressing that data, receiving that data and confirming that data has been received in the internet world. The ICONET project we worked on, the EU-funded research project, worked out what would be required to build the physical internet and defined 4 consolidation services, so sort of technical IT services that a physical internet service provider must offer to allow the system to do that, to create standardized language, to optimize the flows. And these are basically in sequence shipping, encapsulation, routing, and networking.
Just as a matter of interest, what does encapsulation mean in 3 or 4 words?
Effectively, how goods are packaged.
I think that's a very good answer.
So putting a box within a box within a box.
Yes.
Yeah.
No, that's fine. Yeah, you're right. ICONET demystified a lot of the data jargon, but looking at the sort of workload that might be involved, can standardization of information be automated?
Potentially, yes. I mean, there's leading edge machine learning, which is making it possible to identify packets of data from the patterns that are in the data. However, that is probably not reliable enough at the moment in the near term to make sure that's usable. Most users will integrate data using sort of classic middleware solutions, so use of application programming interfaces, which you'll often hear described as API, basically is the translation language that allows one set of data to be matched to another, and some manual matching to set up that translation, at least at the beginning of an operation or somebody entering the network, at least until AI solutions have matured.
This is, for me, one of the really exciting bits. How will sensors be deployed to capture the real-time information required?
Okay, well, yeah, sensors have been developed to enable reliable connected containers, for example, but there are limits to their capabilities. So trains enter tunnels and then signals lost, for example. But the consolidation and triangulation of many sources of data, so connected pallet, a connected truck, a connected train, even a connected box of a set of high-value goods, should allow for this, and along with the other information that's already known, what's already been loaded onto a train or truck, and should overcome the need to connect everything with new sensors. As I've just sort of alluded to, really, much of the logistics infrastructure is already connected in some shape or form: trains, trucks, ships. So the costs of newly deployed sensors is an important question. Logistics service providers themselves will probably not invest until their clients ask them to, which creates one of those chicken and egg type issues. One solution may be mandatory use of connected pallets for urban last mile delivery, the sort of thing which local governments and retailers could mandate, for example.
Just going back a second to the automation of shared logistics planning processes, what do we mean by that?
Okay, so the order processing is achieved via automation, so no need for manual intervention. This would mean orders for transport and logistics, such as an order for a dispatch or goods to a customer, are pooled. So the sort of thing that's automated already in a mainstream retailer or through a parcel delivery company, but is pooled, and then this pooled set of demands from multiple users is then self-organized via the virtual models that we've talked about in the physical internet platform to generate transport orders for all logistics providers within the shared network.
Yeah, yes, I understand that, but how do the physical internet planning platforms allow orders to self-organize to generate a transport order?
Okay, yep, it's probably worth illustrating via the services I mentioned a moment ago that were developed for the ICONET project platform. So as today, the freight forwarder creates an order, for example, so real demand is driving the system. The physical internet platform service provider, the service provider that runs that virtual model and data hubs, consolidates an order with all other demand, and for each order generates a smart contract, which is recorded via blockchain technology to create a secure distributed ledger of transactions. The physical internet platform service provider then provides services that process that order. Firstly, the shipping service engine applies the data model and creates a physical internet order, attaching this to the smart contract. Next, an encapsulation service engine describes how the order will be packaged. This service, effectively an algorithm and specific functionality within the platform, decides and assigns the container information attached to that container. So packing requirements, handling, such as use of space in a roll cage, and mode of transport, such as an intermodal shipping container. Next, the routing service engine considers the options for optimal route. The network service engine then considers networking solutions. And to do this, the network engine requests information on availability within the network, which means that the networking engine will have to interrogate external data, other hubs, other platforms. And here, the cloud-based Internet of Things service engine consolidates capacity within the transport routes that are shortlisted as possible solutions for this distribution problem. By doing this, the networking engine then has a picture of the supply of logistics capacity, such as space on barges, empty running on trucks. The cloud-based platform allows the networking to interrogate external data and then decides the network of logistics service providers that will provide the service. And finally, calculates the detailed planning route for this order and this container, creating the shipping instructions. All of this data is included in the smart contract, where the information can be accessed if authorized and relevant to that particular party.
This really sort of set out the way that ICONET came to some of its conclusions. We were both lucky to be involved in that project, ICONET, EU-funded study into the making of the the physical internet a reality, and it was exciting to see it. The living labs within that research project explored how the physical internet could be used to improve warehousing, transport, port management, and last mile logistics. And if you've ever seen the Port of Antwerp laid out in the way ICONET did it, you would be very interested. If you consider those living labs, what kinds of solutions do you think could a physical internet logistics network deliver?
Yeah, absolutely. I absolutely agree. I mean, the examples that we saw constructed were fascinating. I mean, a physical internet network can be seen just like the data internet as an endlessly connected network within which there are nodes of activity. These nodes and hubs are areas of local optimization. The ICONET Living Labs provided examples of what can be achieved. I mean, I liken it almost to a fractal diagram. Is the further you get in, the more detailed it gets, and the further you go out, the bigger the picture continues to become. So just quickly running through the 4 labs we looked at. First, the Port of Antwerp, as you just described. which explored how to optimize processes both internally within the port and for the externally integrated logistics chains, so the hinterland beyond Antwerp into Europe. And the project highlighted the role of ports as drivers of integration and the role the physical internet can play in smoothing flows of goods of information, including customs information, for example. So the impact of the port is well beyond just the port facility. It's into the deep sea and short sea, and it's into the hinterland that it serves as well. Secondly, the second living lab, Procter & Gamble, helped the project to explore how the physical internet could enhance high volume freight corridors, so generating economies of scale and moving consolidated freight over longer distances. And this lab highlighted the benefits of volume in delivering shared solutions and the value of integrating real-time information to manage those high volume traffic flows. And it delivered very striking reductions in CO2 as a result. The third lab that was particularly dynamic was the Portuguese retailer Sunai, who helped the project understand what is required to use the physical internet to deliver better last mile delivery services, optimized around the constraints of the urban environment and home delivery customers. This was particularly clear in the pandemic when they had to increase their throughput dramatically, and the ICONET project did actually play a key role in helping them to do that. So this lab demonstrated logistics efficiencies, but also the huge gains in product availability and therefore revenue and margin gain that can be unlocked by more effective final mile delivery. And finally, the fourth lab was a French startup called Stop Booking, which is a booking platform for shared warehousing space, which allows users to rent or sell storage space across a network of warehouses across France as required, and for inventory managers to deploy their stock tactically to create an optimal geographical coverage. The lab demonstrated the benefits of a flexible network of inventory management, including, again, better environmental outcomes and better product availability.
So how do these different hubs, such as ports or shared warehousing, combine in this really intensive data flowing network and to provide interoperability of services? Because we've talked about, a port, and we've talked about last mile. I mean, can you actually combine these services?
Yeah, absolutely. And I think this is where the necessity for standardized protocols, data exchange, becomes essential. I mean, a physical internet logistics and transport ecosystem, involving lots of different hubs and players, will organically grow as more operations, more services and users begin to plug into the system, become part of the physical internet network of hubs and flows of information. So I see it as a dynamically growing network of hubs, different types of users, different types of environments.
That's good, and I understand that, but maybe we should just try and summarize a little bit at this point what a physical internet network would actually look like.
Okay, yeah, so again, I think we'll use a representation of some of the living labs within the ICONET project to illustrate the potential. So ports are as I said, the engines of combined logistics flows. They are today, and physical internet hubs that better optimize the cargo within them will synchronize activity with multiple users, including those operating the hinterland routes and sea routes that service the port. The port hub will need to communicate and synchronize activity with other shared services, such as a shared warehousing network that we've just described. Key transport routes will also be integrated, so high volume freight corridors, such as the 10T network of major flows in Europe, will be effectively forms of hubs themselves, increasing the freight throughput, delivery frequency, integrating shared warehousing and ports as part of a wider system. We've seen the massive growth of home delivery since the beginning of the pandemic, and that was illustrated with Sunai. And these services will also need to be fully integrated into the end-to-end flows, delivering sustainable last-mile logistics as part of a wider system. And all these physical internet hubs will combine to create a network of networks. So there'll be an overall integration service platform or series of service platforms connecting many different hubs together. And the entire system will be open access. So open for use by multiple suppliers, supply chains, retailers, manufacturers, service providers. And once these platforms gain scale, users and momentum, they will hopefully become self-sustaining at that point.
That really is the key question, isn't it? Making this a reality. It can't happen like overnight, and it can't happen all at once. It'll have to grow. So how can the early adopters be encouraged? For example, should cities make use of shared hubs and services mandatory? Having a single service to the high street, as it were, both physical and virtual hubs being managed that way.
Yeah, I agree. I mean, this is the difficult part. I think the technical stuff is a technical problem, but getting people to act is the more tricky bit. So I mean, I think the vision is clear. The road to get there is less clear, I think. Change is difficult. We know that. Collaboration even more so, both requiring frequently underestimated investment in cost, time, energy, and people. But I think it's about selling it really in terms of, I mean, the aim of the physical internet is to make collaboration lower risk, easier and more secure. And getting companies to use it will mean that the barriers and cost of entry for them to do so must be low. I mean, the benefits are there to make a business case. Using the physical internet services gives access to pools of assets that encourage collaboration and also offer competitive advantage, which sounds like an impossible outcome, but it effectively delivers both through cuts in lead time for participants, cutting cost, cut of environmental impact. The automated auditing itself and virtualization of documentation should be appealing to many as well as part of the business case, from service buyers through to customs authorities, for example. But the entry to using the system cannot be such a barrier that companies dare not risk expenditure. I think that's the key thing. And now that's even more, I guess, apparent than it ever has been with current constraints on resources. It's worth thinking about Amazon for a moment. Building a capability and service meant years of losses before Amazon became the default platform for many retailers and their logistics provision, not just Amazon itself. And the hubs of hubs that we're talking about could generate similar network effects without becoming monopolies, just by becoming natural destinations, becoming the most attractive service at scale. However, I think to get things started, there's a clear case for government intervention and support. Lack of collaboration delivers negative environmental impacts and could be perceived, therefore, as market failure. Therefore, governments mandating the use of physical internet hubs, particularly in urban areas for final delivery, hubs that they support via investment themselves as government investors, would accelerate the take-up and establishment of the components within the ecosystem that should create an organic growing network, which becomes therefore self-sustaining.
One of the things that we've left out slightly from our discussions, and we're talking about the benefits and saying how some of the transport operations are relatively inefficient currently, is that there is such a drive and such an understanding of the shortage of drivers at the moment that it seems silly that with such numbers not being available, that we then still send the truck out or let it run a third empty for a lot of the time. And these sort of systems would actually help to overcome that requirement, and drivers become another resource which gets plugged into your physical internet. But you raise a really interesting point about the fact that some of these things take time to mature and cost money while they do so. So how can you make the cost of entry low for users? Particularly the logistics service providers who provide most of the assets that are used in distribution. How does it work for large retailers? And just as importantly, given the numbers of small retailers and small suppliers, particularly even in parts of the UK, how do you stop discrimination and making it so easy for the very large suppliers and users to get the benefits, and then the small guys get priced accordingly? How do we stop that?
Yeah, I think this is the critical question, really. It's the commercial, it's the commercialization, isn't it, which will make it accessible and usable. I think a pay per use service is the only way to make access scalable and affordable to service users. I think if we think about things like Microsoft 365 or subscription for any other service, really. I mean, logistics service providers present a more challenging question, as they will need low cost access to any hardware that needs putting in place, such as sensors, which aren't, any sensors they don't already have within their systems to gather that real-time data. I think going back to government investment in physical internet platforms could be underscored by subsidized access for hub subscribers to the sensors and other devices made that will be required to make a logistic provider's infrastructure connected. So linking subscription to the platform with a subsidy for those sensors where it's required, where the business case is generated and validated. Governments could link the take-up of enabling sensor technology with the use of the collaborative logistics platforms. Having said that, what governments should probably avoid doing, especially in these difficult times, is using stick without carrot. You cannot encourage or mandate use of shared logistics without offering support to the means of making it accessible and investment affordable. So let's say, for example, in urban areas, you mandate that final delivery has to be through a shared platform. Alongside that, there could be some encouragement via subsidies for some sensors, for example.
So how do we make the systems easy to install and use?
Yeah, I think, again, it's worth looking at today's digital subscription models. It should be thought of maybe as using an app on the phone or a plug-in capability on an existing company website. The API that we've discussed already and existing system should be easy to integrate, so without change requests or consultancy costs or upgrade costs. So be modular, flexible, sort of plug and play interfaces. To do that, the platforms will need to be robust and reliable themselves. They will need to be able to contract an equally distributed network of cloud storage and processing services to suppliers to them, So, data management companies. Replicating the logistics system with digital twinning and simulation will need a lot of servers, nodes with backup capabilities, and the ability to switch and reallocate processing to avoid system and platform overload or non-availability of service. Users will need guarantees on security. Strict access protocols will be required, again, with security guarantees backed to some extent by the host organization, so the data service provider behind the platform, so guaranteeing the platform has security. Some underwriting by government investors might also help as part of their support.
Who will be the investors in these hubs? Just governments, or can they be made an attractive investment?
Yeah, good question. I think the first investors are likely to be a consortium of parties that are able to back the leading component solutions with an eye on clear, immediate, measurable benefits, such as border customs controls, for example. I mean, these early benefits probably favor government agencies, plus potentially some global logistics providers, although of course, there's a slight dilemma there in that the latter already have many of their own solutions. Certainly, smaller companies and authorities have more to gain than larger companies from the scale benefits of shared systems. But even the largest companies will benefit from the snowballing of users and logistics capabilities offered by this shared physical internet system.
I suppose this is a slightly political question, but can you see the UK government getting involved?
Okay, yeah, I'll try and avoid being political. So it's clear that the UK government would like to improve the flow of freight at borders inside and outside the UK. So they should be an ideal candidate, really. In the end as well, I guess being an early adopter and pioneer should bring benefits. The governments and logistics companies that can attract investment and dedicate energy and time to building early leading platforms of this kind and networks of this kind should gain a competitive advantage. They could build the platforms and physical internet service providers that become global leaders and able to export and replicate this service globally. I mean, whoever gets there first, whether it's EU, whether it's China, the US or the UK, will be leading a green revolution. A shared and open path with a clear direction which others can join that should enable big savings in carbon emissions, a step change as well in the cost of logistics, and more intelligently flexible infrastructure that all are able to join. Such an infrastructure should make collaboration easy. I hesitate to use that word, if not effortless. Easier is probably a better way of putting it. So I feel that there's a push to the UK getting involved, but also a pull potentially.
You mentioned collaboration again. I think actually this is a really misunderstood concept. It feels as if, for many, as if it's at odds with competition. So there's these two schools. One says, I'll collaborate. The other says, no, I'm competitive and I'm competing. And how can I compete if I want to collaborate? So most of today's collaboration is one-to-one. People have found collaboration almost at times by accident. And there are very few incentives to work to either standard contracts or with standard liabilities. There are real fears of collaboration, loss of control of assets, capacities and prices, not knowing, loss of control in the sense that if I have a contract with a 3PL, it means that's my warehouse. My goods have priority number one in that warehouse and on the assets that move the goods from there. And I think I think this misconception about what the physical internet could do actually prevents companies looking for better use of assets and service providers. They want to have the feeling that their assets and services are protected from others wanting to use them when you might want to use them yourself, even if you don't use them particularly efficiently.
Yeah, yeah, I think that's very well illustrated. I mean, so how do you see those fears of collaboration being overcome?
Well, there's always the question of if there are efficiencies to be gained, there are savings to be had. And people want to see the fair share of savings. And the projects that I've been involved with, EU projects I've been involved with, ICONET and CELS, for two of them, actually taught a number of things, which was that having very fixed ways of looking at collaboration in terms of savings and trying to set out in great detail how one would share the savings usually killed them. You spent more time trying to offset every single concern that you might have about where things wouldn't work quite correctly and how would you deal with that tiny bit of extra cost, rather than actually getting on with the physical realities of how do you make the collaboration work. And therefore I think what's important is that the Internet of Things, the Internet of Logistics, the physical internet, seems to offer real transparency, not of details in cost, but transparency in who's moving what and what could be moved by whom, and so on and so forth. That in fact you will create a market pricing mechanism that actually will drive the savings. Because one thing we do know is that the logistics industry, whilst it could be a lot more efficient, is actually very competitive at the efficiency levels that it is running at. And therefore, as efficiencies increase, so prices should drop. Because if I feel I can get a load by shaving a little bit off my margin that's increased because of efficiencies, I'll do it. And I think it's the transparency that this provides, which allows the market to have the correct pricing.
Yeah, that's very interesting. I mean, effectively creating a self-regulating market that means better use of assets and resources by all, lowering the cost of the overall system to everyone. At the very least, reducing the cost of transport and logistics, reducing the costs for individual users as well. Yeah.
Well, this has been a very interesting discussion, Ben. Thanks very much for all your help and work. It must be hoped that governments and other investors will see the same possibilities as we do, and in times of such stress and change, see what can be done to invest in a very different future. Thanks very much again, Ben.
Well, thanks, Steve, and also to CILT for the opportunity to discuss this topic. Hopefully we can revisit the emergence of the physical internet in the not too distant future to see how it's emerging.